Hi everyone, in the previous lectures we have designed an antenna which was the microstrip patch antenna. We got some results, we plotted their results. It include S11 parameters, some E field, H field, current, surface current, density and many more. Now in this lecture I will teach you that what is the effect of these parameter list in the results of the antenna. So we will go to the parametric sweep here. So I will select the new sequence, new parameter, as I'm interested in the width of the patch, so which is the PW. If I click on this page width, you can see it is 36 in length. So I am going to change this page width. So I'll go to the sequence and I will select a new parameter, and the PW here in the parameter list represent the page width. So I'll click on the PW and I will click on the linear sweep. I'm interested from 35 to 37. So the number of sample that I need is strip width, and I will use 0.5 here. So I will get 5 linear results for this simulation. I will get the 5 S11 plots for this simulation. So I will now start the simulation. So I will click on OK. So now I have obtained the results. As you can see that I have obtained the results. So now I will check the variation of the page width and its effect on the S11 plot. So I will go to the S11 plot. So I will select it from the results here. So this is the page width. So I will open the S11 plots. I will double click on this, and you can see these are the results. So these are 5 different plots, and each plot is for a different page width. So you can see that in the results navigation for the 36 page width, you can see that we have this type of result. For the 35 we get this result, for 35.5 we get this result, for 36.5 we get this result, and for 37 we get this result. So with each result, by changing the page width, the depth is changing, and moreover we can also see that a 10 dB reflection coefficient, or at S11 equals to minus 10 dB, and the bandwidth is also increasing. So we are interested in here. So as we have seen it, by changing the page width, this depth or the reflection is getting more minimum. So the depth is getting more lower. Since we are interested in shifting this depth to some desired frequency value, so we want to shift it. So we need to change some other parameter here. So in order to get the result for some other parameter from the parametric list, I will go to see that what effect is caused by the other parameters on the results. So again I will go and look into the 3D parametric list, that what should I change. So this time I am going to parametric sweep. I will delete the previous results, and I have already added, so I will delete it. So I will add new parameter, which is the FW, and the FW is the feed line width. So we will be changing the feed line width from 1.5 to 2.5. we will be changing it and we will be getting results. So this is strip width and 0.5 is the width. So here this is the feed line width. I'm interested in changing this one, and to see the result by changing different feed width, what effect is caused by the S11. So we will look into this. We are getting 3 results, so I'm going to change it further. I'm going to take it 3. So from 1.5 to 3 with 0.5 gap, we will get 4 results. So again, I will start the simulation. So this time the feed width will be changing to different values, and we will be getting the results, and that results would be related to S11 parameter, and we will see that what is the S11 parameter at different width of the feed line. So this simulation will take some time, so we have to wait for the results to obtain. So now the simulation is completed, and we can now analyze the results. So we can see that the simulation process is complete, and these are the parametric list. So we need to go to see the S11 plots. So by clicking this, we see these are the S11 plots. So I got different results, and you can see that we have multiple different results. These are 8 results. So in order to see that what is the result for the pulse width, which was 2. So this is the feed width, and these are the patch width. So these are the 2 different variations. So for the feed width and for the patch width, we have got a total of 8 results. So you can see it here. If I click on different results, you can see the S11 plot is changing. So these are the page width of 37 with the feed width 1.5, with feed width 2.5, and you can see that the depth is getting wider. You can see that we have more bandwidth for this type of combination. At minus 10 dB, we can see that we have this type of result. So as we can see that by changing these parameters, we can make the width wider or sharper. So these are the 2 different changes, like in the feed width and in the page width. We have made 2 changes, and we have got different results for that. So by changing each parametric list, we can get different results. So we can change different parameters from the parametric list, but we cannot change the copper thickness and the substrate thickness, because these are the predefined values. We cannot change it. So we can change any other parameter except the copper thickness and the substrate thickness. So we can change the width and length, page width, page length, feed length, feed width. So we can change all these other parameters, but we cannot change the thickness of the substrate and thickness of the copper. So if I change the page length, I'm going to create another sequence, and I'm going to create another parameter, which is the page length. So I want to see the results from 27 to 29, step width of 0.5, 0.2, or 0.5 will be okay, or I may change it further, but 0.5 is okay. I will get 5 linear results for this variation. So I will start the simulation. Now I will see different results for variation in the page length as well. So the page length will be changing, and the results will be obtained, and those results would be saved in the results section of the antenna. Now the simulation process is complete, and you can see that the simulation process is complete, and you can see the page length is 29 here. I can double click on the S11, and now I can see different results. You can see that somewhere the result or the operating frequency of the antenna has shifted slightly to the low frequencies. So you can see that these parameter FW2, PL, and so these are 3 different variations in the antenna parametric list, and we have obtained a total of multiple different results. So the PL is 28 here. Here 8 results number 9, we have the PL is equal to 27. For 27 we get two bands. You can see that for 27 I do not get any result. For the number 10 I get result because the reflection coefficient is lower than minus 10 dB. So below minus 10 dB, that frequencies could be considered, that at these frequencies the antenna can radiate because the reflection coefficient at these frequencies is lower. So we can only consider minus 10 dB, lower than minus 10 dB. So you can see the results of all these different patterns. Like in these patterns, 3 parameters are changing. You can see here a 28.5 PL, 37 PW and 3 FW. The frequency band 2.4 GHz has been touched by the reflection coefficient plot. So we will go to the home and we will click on the parametric list, and this was the first sequence. This is the second sequence. I am going to delete it, and I am going to delete the sequence 1 as well, and I am going to create a new sequence from the start, and I am going to just only change the PL. So now the PL will be from 28 to 28.5, and the number of step width would be size would be 0.1, and I will get 6 more results for these variations in the page length. After starting the simulation, we will get more results within that range, which is simulating. Now after the simulation is completed for the parametric sweep, we will get more different results. Now you can see that the simulation process is complete, and simulation process is now complete. We will go to the S11 parameters here in the result section, 1D result section. So we have obtained multiple different results. Some results are quite much better than the other. Now we can see that the PL is changing. At 28.1 we get this result, and 28.2 we get this result, and 28.3 is perfectly aligned with 24 GHz. So 28.4 our frequency at 28.3 our antenna is operating at 2.4 GHz because the dip is purely pointing towards the 2.4 GHz. Now, so from these parametric sweep result, we have obtained that at 28.3 page length we get perfect result. So I will fix this value to 28.3. So the page length will now be considered as 28.3 GHz, 28.3 millimeter. So at 28.3 millimeter, I can get the S11 perfectly pointing towards 2.4 GHz. So it means that my antenna will be radiating at 2.4 GHz at this page length. Now after knowing that 28.3 PL is the best page length, we will again simulate this design to see that what is the gain of antenna for this fixed value of the parametric list, as we have already added the field monitor here. So I will start the simulation of this design, and we will keep this PL as 28.3, so it will not be changing. So these are different results which we have obtained using the parametric sweep. So for this 3D design, now I am going to delete the previous results which we have obtained for different pattern, for different variations, and now I will again simulate in the clean format, so I may only get the desired parametric list, the results for these desired parametric list. So I'm going to keep this PL as 28.3, and the other parameter is also, parameter list is also constant here. So I will go to the home and I will start the simulation. So after the simulation process is completed, we will get the results and we will see the S11 plot, and we will come to know that at what frequency or antenna is operating. Now you can see that this is the S11 plot, and you can see that the bit dip is purely pointing towards 2.4 gigahertz, and you can see these are the 10 minus 10 dBm minus 10 dB. We have these two points, S1 P1 and P2, and for these P1 P2 we get a 2.3765 and up to 2.435. we have the antenna bandwidth. So this bandwidth include the desired frequency, which is 2.4 gigahertz. This was the S11 parameter. Now if we want to see the gain of this antenna, we will go to the far field section and we will click on this far field, and you can see that these are the far field radiation. We can check the directivity, gain, realized gain. So we will click on this one, and you can see this is the realized gain. We can see is 2D, and we can also see the polar plot of this gain plot. So this is the gain plot in the polar domain. So we can see that the main lobe magnitude is 2.55 dB. We can also see some other results, like we can see the E field. So this is the E field, electric field. We can also animate it, and we can also see some other results by, we can change this slider, and by zooming it you can see that the current E field is radiating from the patch. We can also see so this in this lecture we have learned that what is the parametric sweep and how these parametric lists affect the results in terms of S11 and gain, and we have seen different polar plots, 2D plots, and radiation patterns. So in the other lecture we will see that what is the effect of slot in the antenna. So we will see.